Welcome back, students. In this video, we'll be continuing with the problems which are based on dependent sources. And today we'll be discussing regarding the superposition theorem. How actually we are going to use this theorem in the questions which will be containing dependent sources. So we'll be starting with the first question and then concepts will be more and more clear. So let us start the question. There is an independent voltage source. This is an independent voltage source that we are having here. And we are having a dependent source also. So this is a dependent source, diamond shape, and it is dependent on the voltage actually. So it is a voltage control current source. And it is given that we have to find this Vx, and the method we have to use is a superposition that is given in the question only. Now, before I start this, I will recall what you have understood from the superposition principle in previous videos. So the first step in superposition is we will be actually checking the current or the voltage that we have to find individually from each and every source. So if suppose in this question we are having two independent sources, correct? We are having a voltage source and a current source. So if I want to know this Vx, that is the unknown here, I will see what is the contribution of 25 volt in this particular voltage, and then I will see what is the contribution of this 4 ampere. So at a time only one independent source will be used, others would be turned off. So that is what is the next thing you have to understand, that we have to turn off other independent sources. We have to turn off other independent sources. So when we say we have to turn off, it means if there is a voltage source you have to remove, so we are going to short it. And if there's a independent current source that we have to remove, then we have to open it. And then we can find the contribution of only one source. And then in this question, there is one thing extra, that is a dependent source. So what we have read in the statement of the superposition theorem is, if suppose you are having dependent sources also as a part of the network, because they are dependent on some other parameter, they are not independent, so they will be left intact. It means we are not going to remove it. Don't remove them. Okay, so let us now start solving this particular question, and I'll be first checking the contribution due to one voltage source and then with the other current source. Then I will be simply adding up the two answers. So let us start with the analysis. So we can start with case 1. So in case 1, I will take only 25 voltage source. It means I am taking this source, so this current source has to be removed. So my circuit diagram would look like this. Now current source I have to remove, and then there is a resistor. And since this is an dependent current source, so I have to keep it in the circuit. So this is how the circuit will become. Only one thing is different in this one that I have drawn, that this 5 ampere is not part of it because I am taking the individual contribution of independent sources. So this is 25, this is 20, now 4 and 0.1 Vx. Now we have to find this Vx. Let us call it right now Vx1. So this voltage is Vx1, and this is a single node. Now you can use any of the methods. Let's use the concept of you can say nodal analysis. So this is the current that is moving in this branch, 20 ohm resistor, and we can assume this as one more current. Let it be I1, let this be I2. So we can use KCL at node X. It means this is the X node, we are applying here the KCL. So it means currents which are entering are equal to currents that are leaving. So what are the currents that are entering? If you see this node, this current is entering, and this current is also entering a node, correct? It is moving this way, and I2 would be leaving. So you can write I1, that is entering current, plus 0.1 Vx is equal to I2. Now we'll be using you can say Ohm's law to convert this I into V by R. So I can write 25 minus Vx1 upon 20 plus Vx1 by 10 is equal to I2 is Vx1 minus 0 because this is the reference node, so it is 0 volt. So I can write Vx1 upon 4. I can see there's only one unknown over here, so I can write 25 by 20 is equal to, I will take all the terms towards my right. It will be 1 by 4 plus 1 by 20 minus 1 by 10. So once you'll be solving it, you will get Vx1 equal to 25 upon 4 volts. So you can solve it, and this is the Vx1 that you will get. There's only one unknown over here. So this is the contribution of this voltage source in this Vx, but this is not the final answer because we are still pending with case number 2. So what is my case number 2? Case number 2 is we will be taking the effect of 5 ampere. So we will write take only 5 ampere source now. Now let us again redraw the diagram, and we know that voltage source has to be shorted now, and current source is there. Then there is this resistor, and again this dependent source we cannot remove it, so it has to be a part of your circuit only. So this is how the diagram would look like. This is V8, this is 4, this is 5 ampere, and this is 20. Now again we can use actually nodal analysis. So we can assume some currents. Now this voltage node, we can call it right now Vx2. This is the node voltage. So the node voltage at all these points is same, and this is a single node. Now we can assume the currents that are in this resistors 4 and 20. Let it be, you can say, away. They are moving away from the node. The current directions, as I have told you in the nodal analysis, that first step is you have to assume current directions. Assume current directions. So I am just assuming it. You can take it entering or leaving. That is completely your choice. And let us call it, suppose I1 and I2. Now if you see here, this is a single node. To make this thing a bit easy for you, it is like this. There is this resistor, then there is this 5 ampere, and on the same node we are having 4 also, and on the same node we are having this 0.1 Vx also. So there is a single equation actually that is required over here. And again you can write currents that are entering is equal to currents that are leaving. So you can see here this current is entering and this current is also entering, and according to my directions I have given for the resistors, and these currents are leaving them. So we can write 5 plus 0.1 Vx because they are entering currents is equal to currents that are leaving, that is I1 plus I2. So again you can solve this. You will get 5 plus Vx by 10 is equal to, now what is I1? This is Vx2 and this is the reference. So you can write simply Vx2 upon 20 plus I1 is how much? Vx2 upon 4. So again you can solve this. You will get 5 equal to Vx2 1 by 20 plus 1 by 4 minus 1 by 10. So once you'll be solving this, you'll be getting this Vx2 equal to 25 volts. Now what we have found out is the Vx, this voltage with the contribution of 25 volts also and the 5 amperes also. Now finally then I can write, so total voltage. Total voltage means actually what was required for us, that is Vx. I can write this is equal to Vx1 plus Vx2 because this is what the superposition is. Individual contribution due to every independent source. Then you have to simply add it up. The first answer is 25 by 4, and if we will do its calculation, it will be 6.25 volts here. So we can now simply add two answers. One is 6.25 volt and the other one is 25 volt. The total Vx that you are getting is 31.25 volts. So this is your final answer. So what you are realizing actually in this question, although we did find the answer, but if you are having dependent sources also as a part of your network, then things become bit you can say lengthier and difficult with the superposition. But sometimes it is easier also. So we should know the method regarding the analysis. So what we understood from this question is if there are dependent sources, this is how they must be a part of your network and you cannot remove them. And then you have to use nodal analysis or mesh analysis depending upon what is feasible for the question, and you should be able to get the answer. The rest of the points are same like we do for the normal questions which are not having dependent sources. The rest of the steps are same. Only thing that was new in this question was dependent source must not be removed. Now what I will be doing is we got the answer as 31.25. Let us solve the same question using nodal analysis. Same question using nodal analysis. Now let us see how can we solve. So again I am repeating here what are the steps. I am recalling the steps for nodal analysis. So the first step is we have to assume current directions. So once I say assume, so it means you can have any direction because you see this current is given, this current is given, but for these two you can say resistors, the current directions are not given. So assume any direction. Then we'll be applying KCL at the node. Use Ohm's law to convert your I into V by R form, and then we'll be solving our equations. These are the steps we have to follow. Now let me start with the first step. I will be assuming that suppose this is current I1 and let me assume that this is current I2. And the fact that it is a single node, you can actually redraw this diagram for having a clear understanding. So if this is a node, this is your current going this way. Now other two also you can have on the same node like this. So this is a single node actually. So one equation is sufficient. And you can see this current is entering, this is also entering, this is leaving, and this is also entering. So we can say at node X currents which are entering is equal to currents that are leaving. Correct? So accordingly I can write what are the entering currents. I can write I1 plus 5 plus 0.1 Vx is equal to leaving current. So leaving current is what? I2 only. Now we can write this I1 as in the form of V by R, that's the third step. So we can write 25 minus Vx upon 20 plus 5 plus Vx by 10 is equal to, this will be Vx by 4. So what we will get then, 25 by 20 plus 5 is equal to Vx 1 by 4 minus 1 by 10, and this will be 1 by 20. Now you can solve it from here. It would be 125 upon 20 is equal to Vx. So what will be the LCM of 4, 10 and 20? You can do it here. 4 into 1, 4 into 5, correct? So 5, 2 into and 1. So 40 is the LCM. So you can write here 40. So it will be 40 by 4, that is 10. Then it is 4 and this is 2. So what are we getting is 125 by 20 is equal to Vx times 12 minus 8, that is 12 minus 4 is 8 by 40. So we can cancel it out now. 20 into 1, 20 into 2. So again you can see Vx is 2 into 125 upon 8. So again if we will be solving this, we will be getting 31.25 volts, which is same as the answer we got previous in the previous analysis. So it is easier to solve it directly with nodal rather than to go with the superposition. But we must be knowing all the types of methods, and this is how we are expected to solve it. In case you are having some questions, you can post it in the comment section. So all the best and God bless you all. Thank you.